Hello students, in previous lecture we have studied about the derivation for maximum work done. Then today we are going to discuss about the internal energy of the system as well as the first law of thermodynamics and the mathematical expression for first law of thermodynamics. Then first of all we will discuss on internal energy of the system. Internal energy of system, and that is denoted by U. Then what is internal energy? Internal energy is nothing but it is a definite amount of energy which is associated with every substance. That means every substance is related with a definite amount of energy. That energy which is internally stored in that substance is called as internal energy of that substance. Then internal energy of any substance, it is a sum of, that is it is a sum of internal energy of the substance which is related with the kinetic energy of the particles. Every substance, it is made up of small particles. It may be atoms or molecules, and the energy which is associated with that particles is of two types. That is kinetic energy which is related with those particles, as well as potential energy is related with those particles of that substance, and that is nothing but internal energy of that substance. Then which type of kinetic energy is related with that particles? All of you studied about that. The particles of that substance, whether that substance is solid, liquid or gaseous in nature, then those particles which is related with that, or those particles which is present in that substance, those particles having few motions, that is they have vibrational motions or they have rotational motions, as well as those particles moves in a linear ways, that is in a straight line, that is movement of those particles. And here kinetic energy which is related with that particle, it may be translational energy or it may be rotational energy or it may be vibrational energy, as well as the potential energy which is related with those particles. That is, see here, there is interaction between molecule and molecule, that is called as intermolecular interactions, and the energy which is related with that intermolecular interaction is that is of potential energy type of energy, as well as here the molecule which is made up of atoms. Therefore here the potential energy which is related with that structure of that molecule or particles which is made up of from different atoms, that is known as intramolecular potential energy. That means here that amount of energy, that is definite amount of energy which is related with that substance, is nothing but it is a sum of those all kinetic energy related with that particles of the substance, as well as potential energy which is related with that particles of that substance. That means internal energy is nothing but it is a sum of translational energy of that particles, rotational energy, vibrational energy, and intermolecular energy as well as intramolecular energy of that particles of the substance. Then we will discuss about the internal energy of the system. Internal energy of system, which is denoted by delta U. That means here change in internal energy of the system, because system, in the system when process takes place, then system changes from one state to another state. When system is at initial state, then the energy which is related with that system is known as, that is U1. U1 is a internal energy of the system when it is at initial state. That means here initial internal energy of the system, and U2, that is the final internal energy of the system. System changes from one state to another state, then internal energy which is related with that process, that is denoted by delta U, and which is calculated as U2, final internal energy minus initial internal energy. And therefore here that change in internal energy is nothing but it is a internal energy of the system in which different types of processes takes place in that system. Then see here internal energy, which is a state function, that is internal energy because it depends upon that state of system and not on the path followed by the system. Therefore here U, which is a state function, that is internal energy is a state function, and internal energy which is also depends upon that amount of substance, that means it is depends upon quantity of that substance. Therefore internal energy is a extensive property of the system, and that is about the internal energy of system. Then we will discuss about the internal energy of the system by taking few examples of it. Then see here, if heat is absorbed by the system, then that heat energy which is denoted as plus Q, and when heat is absorbed by the system, then here that means energy is added into the system, and here change in the internal energy, that is positive, that is delta U is positive, because here energy is transferred into the system, added into the system. Here work done takes place on the system. Here work done takes place on the system, and here delta U is positive, and here work done when takes place on the system, then work done that is also positive. Here if heat is released from system, then here heat energy, that is Q, is denoted as minus Q, that is negative, and here delta U, change in internal energy of the system, that is negative, because here work done takes place by the system, and here W is negative. That is, work done takes place by the system, then work done is negative because here in change in internal energy is negative. That is about that sign conventions related with that internal energy. Then I am going to discuss with you about the few examples related with internal energy of the system. Internal energy of system, that is delta U. Then see here, if 30 kilojoule heat supplied to the system, then here delta U is plus 30 kilojoule. That is change in internal energy, or internal energy of the system is positive, that is plus 30 kilojoule. If here 20 kilojoule heat released from system to the surrounding, then here delta U is minus 20 kilojoule. And if here 10 kilojoule heat is released from system, and at the same time 15 kilojoule work done takes place by the system, then here internal energy of the system is, that is here minus 25 kilojoule. That is here work done takes place by the system and 10 kilojoule heat is released from system. Therefore change in internal energy, that is delta U, is minus 10 kilojoule, as well as work done takes place by the system. Therefore internal energy of the system decreases by 15 kilojoule. That means here total internal change in internal energy of the system, that is minus 25 kilojoule. That is about the few examples which is related with the internal energy of the system. Then we will discuss about that is first law of thermodynamics and mathematical expression for the first law of thermodynamics. Then see here, first law of thermodynamics, and that law is also known as, or it is related with the conservation of energy of universe, conservation of energy of system or universe. Then see here, universe is one of the isolated system, and see here the first statement of the first law of thermodynamics, or this law is also known as energy conservation law. That means here energy neither be created, it cannot be destroyed, but it can be converted into another form in equivalent amount, in equal amount of another form of energy is obtained here. That means here energy cannot be destroyed or it cannot be formed or created, but it can be converted from one form to another form. That means here if Q amount of heat is provided to the system, if that is of 10 kilojoule, then the few amount of that energy which is used to change in internal energy of the system and the remaining energy which is used for work done takes place in the system. That means here suppose 10 kilojoule heat is provided to the system, then out of that 10 kilojoule, here 5 kilojoule heat is used to change in internal energy and remaining 5 kilojoule heat is obtained in the form of work done. That is the energy conservation law, or it is the first law of thermodynamics. That means here when electricity is consumed, then it converted into light energy as well as into heat energy in different types of electrical gadgets. That is the one of the example of energy conservation law. And here one more statement, see here, energy neither be created in the system nor be destroyed. That means here one form of energy is converted into another form of energy. That means here that total energy of universe remains constant, and that means here energy of the isolated system is always constant. Energy of isolated system is always constant, and from those concepts we can write the mathematical expression for first law of thermodynamics. That is here internal energy of the system is the sum of heat transfer takes place with system and surrounding as well as work done takes place in the system. That means here delta U is equals to Q plus W. Here the change in internal energy, whether it is positive or negative, which is depends upon, that is heat transferred to the system or heat exchange of heat takes place between system and surrounding. Then see here that first law of thermodynamics can be stated as change in internal energy of the system is the sum of heat transferred takes place between system and surrounding as well as work done takes place in the system. That is the first law of thermodynamics. Then we can apply this law of thermodynamics for various processes. Then all of you studied about that. There are different types of process, that is isothermal process, adiabatic process, isochoric process and isobaric process. First of all, see here in isothermal process all of you studied about that isothermal. Iso means same, thermal means heat energy. That is here isothermal process, T remains constant. That is temperature of the system remains constant and therefore delta T is 0. And whenever delta T is 0, then delta U is also 0. That means here change in internal energy, that is always 0. Therefore here we can apply that first law of thermodynamics for this process or in this process, that is here delta U is equals to Q plus W, and here delta U is 0. Therefore putting the value of delta U, we get the equation, that is 0 is equals to Q plus W. Therefore here Q is equals to minus W. That means here this equation indicates that here heat absorbed by the system is used for work done takes place by the system. That means if here heat is absorbed by the system, because here Q is positive, heat is absorbed by the system, that is total amount of heat is used to takes place, that is for work done which is takes place by the system on the surrounding, because here minus W is there. Therefore here in this process Q is equals to minus W. Then in adiabatic process, in adiabatic process heat exchange does not take place in this system. Therefore here Q is equals to 0, and here first, according to first law of thermodynamics, delta U is equals to Q plus W, and here putting the value of Q, that is we get the expression of first law of thermodynamics is delta U is equals to W. That means here delta U which is positive and work done which is also positive. That means here this expression which can be written like this, minus delta U is equals to minus W. That means this expression indicates that increase in internal energy, that is work done takes place on the system. Here W is positive, that means here work done takes place on the system. And if here minus delta U is equals to minus W, that means here decrease in internal energy of the system, here that is work done takes place by the system here. That means here in adiabatic process, first law of thermodynamics which is applied in that process. Then isochoric process. Here in isochoric process, here delta V is 0. That is change in volume is 0. That means volume remains constant. And therefore here we know that W is equals to minus PEX into delta V. And here delta V is 0. Therefore here W is equals to 0. And first law of thermodynamics, that is delta U is equals to Q plus W. And here W is 0 for isochoric process. Therefore here delta U is equals to Q. That means this equation indicates that here change in internal energy of the system is equals to the heat transferred to the system. That means here increase in internal energy is related with the heat absorbed by the system. That is about the first law of thermodynamics in isochoric process as well as in isobaric process. In isobaric process. Isobaric process. Here P is constant. P is constant. Therefore, here delta P is 0. And here W is equals to minus PEX into delta V. That means here delta V is not equals to 0. That means here as pressure remains constant, therefore change in internal energy is not equals to 0. That means here the process which takes place in open system, it is comes under the isobaric process. And here therefore delta U is equals to Q plus W, and here delta U is equals to W. The value of W is putting in this equation. Therefore here this equation becomes delta U is equals to Q plus, that is minus PEX into delta V, and therefore delta U is equals to Q minus PEX delta V, and here we get QP, that is at the QP, that is heat transfer takes place within in the isobaric process. QP is equals to delta U plus PEX into delta V. That means here heat transfer takes place during isobaric process is the sum of change in internal energy and here PEX into delta V, that is minus W. That is the equation which is obtained in the different types of process considering first law of thermodynamics, that is about the internal energy as well as first law of thermodynamics and first law of thermodynamics which is takes place in various processes. Then we will study about few more concepts which is related with the chemical thermodynamics in next lecture. Thank you.